The Khipu is a system of writing used by the people in Peru before the Spanish conquest. Instead of writing on walls in letters or characters or hieroglyphs, they tied knots into strings. Unfortunately, today we can't read what the Inca Khipu say. It's a very interesting field of study, and about 2 years ago I decided to study it more seriously and look for patterns. And I was very excited to find out that Gary Urton at Harvard had this Khipu database project where the information on almost 1,000 Khipu is recorded and available to anyone to use online. I was a bit discouraged when I first saw the Khipu database, the numbers. It's very difficult to visualize in a format like this the relationship between the chords. So I designed a program that would make diagrams of the Khipu based off of information provided in the Khipu database. I initially made it for personal use, but I am planning on releasing it to the general public, so if there's any features that you'd like to see, please leave a comment below and I can see about adding those in before release. I'm going to go over some of the basic functionality of the program now. So it starts with a detailed diagram. These colors are in the database. The chord lengths are relative. Everything is drawn to scale. The knots are also placed to scale. This is their relative placement. And right off the bat, we can see that there is some seriation in these Khipu. You can see 5 white chords and a pattern of white, brown, gray modeled. So we're going to look at this later in the simple diagram to analyze the values. And this overview kind of lets us see, get a basic idea of what the Khipu looks like. You can see there's a banded portion here later, and another seriated portion and banded. And then at the end we have this top chord, and it's very easy to see with this program, a lot easier to see than in the database when you only have the numbers. If we go to full size, we can kind of zoom in. So on this first chord, we can see that the primary chord starts with a knot. On this first chord is called X1. There are a lot of subsidiaries. X1 is kind of an unusual name for a pendant chord. So if we go to notes, it'll show us the notes that were provided, and this gives an explanation for what the X1 is about. There's other information about the Khipu, where it came from and where it currently is in a museum. Let's just hide that and go over here. You can see that the single knots are in different conformations. You have 2 of them in an S configuration and 3 in a Z configuration. And over here, these 2 figure 8 knots are also in different configurations. These are provided by the database, the S and Z, and the diagram shows that. And down at the bottom, you have the name of the pendant chord, the S or Z ply, and also a chord value. At the top, you have whether the chord is attached recto or verso, as well as spacing in between the chords. These chords here, there is a space created for the diagram so that they're kept separate. But if there's no spacing listed, that means they're pretty much 0 spacing in the database. And we can look at a simple diagram. In the simple diagram, the chords, the length is ignored, and the chords and the chord values are kind of all that's shown in the colors. And this just makes it easier for us to compare the chords. Down at the bottom, this preserves the original spacing. So we can see the seriated portion starts on this pendant chord named 2. So if we go to Tools, there's an option to start on 2. I believe it ends on, yeah, it ends here 63. I want to, yeah, it looks like they are in groups of 4. There were 5 white chords in the first group. So I want the first line to show, the first row to show 2 through 21. I'm going to increase the columns, reload the image. We can see, there you go, and you can see a pattern already emerging with the chord values. And here we have larger values, here we have larger values, and this third row, they don't quite match up. So we're going to ignore, yeah, 42 and 43 don't exactly follow the pattern, so we're just going to go ahead and ignore that. Now you can see the chords line up really nice. There's a summation down here at the bottom that provides a sum of all of these chords here, and the chord values, which has been shown to be meaningful. And you can also include the subsidiaries. So we'll reload that. You can see the totals here at the bottom change to reflect the subsidiaries. It only shows first order subsidiaries. It doesn't show like chord level 2, just because it would take up too much space. And if we want to add a space in here, you can do that as well. For presentation purposes, there are dotted lines to show kind of where the end, or where the chord continues on, because in reality these aren't 3 separate chords, but one continuous chord. Also, if you'd like to put in alternate values, like if you look at the detailed diagram and you decide, well, this says 508 in the database, but maybe it's 58, then you can input alternate values. So let's change 14 to 58 and 16 to 16, and we'll change chord 18 to 121 and reload the image. And that adjusts also the totals down at the bottom, and you can choose to include those in the calculation or not. You can kind of go back and forth and decide what fits better. If you have a broken chord, you can add in a, assumed value. So if we think, well, maybe this chord is broken and it should have a value of 2, I can add that in and include that in the calculation as well, just to play with the numbers. If we go take a look at the banded section from 65 to, let's just go to 150. So for the banded section, they don't look quite as even as the seriated, so we don't want to arrange them in columns to get a total at the bottom. So let's change the number 5, 10, 13. So we're going to change these numbers to 5 and 13, uncheck the vertical summation, and reload the image, and that, they line up pretty nice. This section also has these knotted markers, so I want to include those on the simple diagram. And it looks like every time there's a marker, the color changes, so that'd be a good place to start a new row. So let's see, 5, 10 here. I'm going to make a few adjustments. So very quickly, we can arrange them into groups. You can also show the totals. So this 274 is a sum of this 5 chord grouping here. The row totals are shown as well. I also have included filters, so you can use the original color, you can show the SZ ply, recto verso, chord termination, and these change the color of the pendant chord so we can very easily see the recto verso attachment. So down here on the 4th row, if we decide that, well, maybe this wasn't a very good separation, we can change this and 11, reload the image. So we can reload the image to the original color. You can save all of the diagrams, and this just saves generic PNG or JPEG file that you can use in other programs to draw, make notes, or whatever you need. So if there are any features that you'd like to see, please leave a note in the comments below. I will be including a link in the description for the software once I do have it published, so keep an eye out for that.
Now let's see how the program works with a few other examples. This is Urton number 11. As you can see, it has modeled chords, and there's possibly some seriation, lots of subsidiaries. If we go to the simple diagram, I'll demonstrate how the program works to look at the seriation. Looks like they're in groups of 5. A rather large space after 76. So maybe we'll only look at chords up to 76. Actually, it looks like the seriation might end at 55. Here we go. Let's see if SC play makes a difference. Probably not. Recto verso attachment. There's only a few in there that are verso in blue. So that looks like it doesn't affect the grouping. Now if we look at the second segment, let's go from 77. Looks like a banded pattern, so I'm just going to split them up by color relatively, a little by spacing. You can see recto verso attachment. The second section has a very different recto verso look than the first section. This is an example of how top chords are displayed. These are just examples I pulled out of the Khipu database. This one, it looks like there are a lot of subsidiaries on each chord. Especially in the beginning section. You can see if there's any difference in recto verso attachment. Looks like all but the first are rectos. May or may not mean something. And this is how the simple diagram shows when you have multiple subsidiaries. Chords 1, 4, 6, 7, 8, 9, they are intended to be short. That means that they have a broken ending. I did this to indicate that the not value may not be what is shown in the Khipu database. If they were broken, they may have had more knots below. Let's take a look at one of the Khipu. I think we'll pick one from Bruchuko, from the Khipu database program. This is what the Khipu looks like, the actual Khipu. You can kind of see in the picture, and now I'm going to demonstrate what it looks like as a diagram. In the diagram, it is very easy to see that there is a seriation pattern. And even in the number values, you can already see a pattern there. Let's just reorganize this a little. And you can add spaces if that helps preserve the pattern. And you can see the totals listed at the bottom. Doesn't look like SC ply or recto verso attachment make a difference here. It looks like there's a really big space after 52, so maybe we'll, and after 33, let's try and line that up. A little better according to spacing. You can see the knots all line up nice. Let's try a slightly different arrangement. I'm going to do 2 lines. So maybe break up the rows, maybe have the first row as that first segment, and the second row is the segment after the large space. 3 rows seems to make more sense. Very easy to manipulate play around with.